Hey grade 12s, welcome to today's video. Today we'll be going over question 3 of Maths paper 2 for the 2020 November past paper. If you don't have the paper, please pause the video now. There's a link in the description where you can download the paper as well as the memo. Once you have it, then we can continue with the question. Okay, let's get started with question 3. So question 3.1 and 3.2 I'm not going to write out by hand because it's grade 10 and 11 work. The first one asks you to calculate the gradient between W and P. So W and P, they've given you the 2 points. You take the change in your Y values divided by the change in your X values. Okay, so just remember that your gradient M equals delta Y over delta X. Okay, and you can then find your gradient. It should give you -2. Okay, 3.2 asks you to show that WP and ST are perpendicular. Now, if they're perpendicular, the products of the gradient of ST and WP must equal -1. Okay, so M of ST multiplied by M of WP must equal -1. Okay, so it's given that ST is a half. We calculated the gradient of WP in 1.1, it's -2, so you can see that they are perpendicular. Okay, I'm going to be focusing on 3.3 down to 3.6. Okay, so 3.3 asks us, with the given equation over here, calculate the coordinate of S. Okay, so we've got to find where ST intercepts SK. Okay, so I'm going to do it over here. So we've been given ST. Okay, that's our first function, g of x. Okay, now we're just going to write SK in terms of y. So y equals then to -2 over 5x minus 12. So that's going to be f of x. Okay, so we're going to find the x value first for s, and that's going to be by equating g and f to each other. So I'm going to say g of x equals f of x. Okay, so we'll have a half x plus 6 is going to then equal to -2 over 5x minus 12. Okay, so if you sort out the algebra, you're going to get -9 over 10x is going to then equal to 18. Okay, so x is equal to -20. Okay, now that we have the x value, this is the x value for s. Okay, now what we can do is, because the two lines intercept over here and we have the x value, we can plug it into any one of the equations and it'll give you the y value. So I'm going to use the equation that was given, so g of x. So I'm going to find g of -20. Okay, which is then going to give me a half -20 plus 6, which is then going to give me -4. Okay, so the final thing we do is we then write s's coordinate out. So s is then going to be -20 and -4. Okay, now I'm going to fill this in on your paper so that you know what it is. -20, -4. Okay, and you don't have to page back and forth. Looking at 3.4, 3.4 says calculate the length of WR. Okay, so WR is this line over here. Okay, please note that W and R share a common x value of -4. Okay, so immediately when you think of length or distance, this formula over here should pop up into your head. Okay, so we have W, we have R, but we don't have R's y value. So we're going to find the y value. How are we going to do this? We're going to substitute the x value, -4, okay, into the equation of SK. So we've just found SK from the previous question. It's this over here. So y equals -2 over 5. -4 goes in there, minus 12. Okay, and that's going to give you a value of -10.4 for my y value. Okay, you can double check that if you want. Once we have that, we can now use this and plug it into our formula. So WR is going to equal to the square root of x2. So I'm going to use x2 as negative 4 minus minus 4 squared. Okay. Plus then y2 is going to be this value over here. Okay, so I'm going to take it as negative 10.4 minus 4, and that's all going to be squared. And if you plug that into your calculator, you shall get a value of 14.4 units. Okay, the other way you could have done it is just by looking at the change in y values for the coordinates. Okay, I'm going to fill this in here. This was negative 4 and negative 10.4. Okay, now looking at 3.5, 3.5 says calculate the size of theta. Okay, so theta is given over here. Okay, so this is going to be quite a tricky one. It's worth 5 marks. Okay, so what we're going to do is, first of all, from Trig, okay, just to show you where this comes from, remember that our gradient is equal to the change in y over the change in x. Okay, so if we draw a triangle, we know that x is my hypotenuse times cos of theta, okay, and y is my hypotenuse times sine of theta. So if we substitute these values in up here, we can see that my gradient is h sine of theta over h cos of theta, which is just equal to tan. Okay, so therefore m, my gradient, is equivalent to tan of theta. Okay, so we now have the formula for ST, so we can work out this angle over here, okay, using what we've just derived, and we have the equation for SK, and SK cuts the x-axis over here. So now we can find this angle and that angle, okay, and then using our rules, we know that theta is going to be equal to the sum of these two angles. Why? Because exterior angles of a triangle. Okay, so let's get started. We know that the line of ST has a gradient of a half, and the line of SK has a gradient of negative 2 over 5. Okay, so m of ST equals tan of theta. Okay, so I'll take the inverse of tan to get theta. So theta is going to equal then tan negative 1 of a half. Okay, and that should give you 26.56. Okay, so now we have the angle of m. Okay, so m over here is 26.56. Why? Because even though we've calculated this angle over here, angles opposite each other are equal. Okay, now we're going to find this value over here. Okay, so now we're going to use m of sk equals tan theta. Okay, so once again, theta equals the inverse of tan. Now we're going to substitute the gradient in. Okay, and that should give you a value of 21.801 degrees. Okay, please note that it's a negative angle. Why? Because we're below the x-axis over here. Okay, even though it's a negative angle, we're going to take the magnitude of that angle. So what we're going to do is we're going to take the absolute value of the angle's value. Okay, so we're going to take the absolute value of this when calculating theta. So theta of S is then going to equal to, okay, the absolute value of 21. Negative 21 becomes positive, so 21.801 plus then this angle over here. Okay, why? Because it's the sum of these two angles equals theta. So plus 26.56. Okay, and if you add that together, you should get a value of 48.37 degrees. Okay, now looking at 3.6, it says we must construct a parallelogram in the third quadrant, okay, using a point L. So I'm going to put my point over here for L. Okay, Then it says we must connect S, W, R, and L. So S, W, R, and L. Okay. Now we need to find the area of this parallelogram. But note that the parallelogram is split into two equal triangles. Okay, it's not drawn properly here, but it's two equal triangles. Why? Because this length and that length must be equal to one another. Okay. But now what I'm going to do is I'm going to find the area of this triangle over here. So how am I going to do that? I'm going to construct a perpendicular height over here. Okay. Why? Because I know this x value and I know this x value. Okay, so I can take the difference between these two x values and it'll give me the height of the triangle, plus we know this length over here. Once I have the area here, I multiply it by 2 and I have the area of the parallelogram. Okay, so let's get started with that. Okay, so we know delta H, okay, is going to be the S, so the x value at S, so the x value at S minus the x value of W, R. Okay, I'm just going to label it that way. And we're going to take the magnitude of it, so we're taking the absolute value. So that's going to be the absolute value of negative 20 minus 4. Okay, it's going to give you the absolute value of negative 16, which equals to 16. Okay, so that's 16 units. Okay, now we're just going to calculate area. We know that WR from earlier on was given as, I think it was 14.4. Let's just check here, 14.4. 14.4 units. Okay, so therefore the area of the triangle is SWR is going to equal half my base times my perpendicular height. Okay, so that's a half 14.4 multiplied by my perpendicular height, which is 16, which gives me 115.2 units squared. Okay, now we calculate the area of the parallelogram. So area of WSRL is going to be 2 times the area of SWR. Okay, and if you multiply that by 2, you'll get an answer of 230.4 units squared. Okay, don't forget it's squared units because we're dealing with area. Okay, and that's how we go about solving this problem. So if you've liked today's video, please leave a like on the video. If you have any questions or queries, please leave them in the comment section below. Also, please go check out the channel for any other videos. There's chemistry videos and physics videos as well. Subscribe to the channel while you're there, and thanks for watching.